Cool. I'm getting the thumbs up. I think we're good to go. We're good, Tien? Yep. Cracking. Awesome. So, hi, everybody. And thanks for coming to my talk this morning, because there's some really good talks on in those other rooms. So there was a moment where I wondered if anyone was going to walk through that door. So I'm feeling quite pumped now, which is really good. And it's so good to be back to an in-person conference as well. So that's also fabulous. So today we're going to be talking about Azure Active Directory, JWTs, OIDC, PKCE, claims, scopes, all these fabulous identity concepts. So I'll give you a little bit of information about myself before we get cracking. My name's Graeme, and I work as a cloud solution architect at Microsoft. I've been there for about 2 years now, but to be honest with you, taking an architect title was a little bit kind of like weird. I've been a developer / engineer for 25 years before that, and managed to resist being an architect, but here we are, that's okay. I still managed to keep relatively hands-on, which is good. Now, in those 25 years, I've seen a lot of different ways of dealing with identity, authentication, and authorization. You know, if you think back many, many years ago, we all used to roll our own username password databases, right? Pretty insecure stuff, but we had them. Every application had its own username password database. Not a good place to be in. Then we had Active Directory. A lot of people might still have to use that today. It's still everywhere, really. But you know, we fast forward, we go through LDAP. I don't know if anyone in here has tried to roll their own secure token server. That's a barrel of fun and really, really unpleasant experience if you've ever tried that. And about 15, maybe 10, 15 years ago, there was a real change in the industry where this thing called OAuth2 suddenly came along. And anyone who's been in the WS Star, WS Federation world will know that that was a criminally horrible place to be in. Like really, really disgusting, really complicated, just enterprise to the extreme. And OAuth2 came along with the idea of really simplifying a common story, which was, I've got something like Facebook, I've got a third-party client, I've got users who have data on Facebook. How do they access that? Now, luckily, most applications today start with OAuth2, OIDC. It's super simple to get going on it, right? And what I don't want to do today is take you through that kind of let's get started, let's set an application up. In my job at Microsoft, it's not uncommon for me to get calls from customers who have got problems with their OIDC flows. And what always strikes me is that whenever we set this up, there's about 3 different things that are involved in it. We've got Azure Active Directory. It could be any identity server, to be honest. It could be Auth0, it could be your own custom rolled Duende, whatever, doesn't really matter. But there's this thing, it's managed by a team. We've got our client applications, and then we have our users. And we always have teams that focus on those individual boxes. But where it gets complicated is that everything has to be just right between those 3 boxes for everything to work. And when it's not, people often don't know where to look or how to go about diagnosing these issues. So that's really the main focus for my talk today. So I want to cover the tools and techniques and show you some of the common classes of errors that I see all the time in the wild when people are trying to set these flows up. We're going to talk about a flow called PKCE. So if you're building web applications or native applications, it's something that if you haven't heard about, you really want to start thinking about moving to it. We're going to break down JWTs, have a look what's inside them, and we want to think about how those concepts in those tokens relate to identity and authentication and authorization. And finally, we'll look at scopes and groups and roles and have a think about what they are, and again, how we can use those to kind of build authorization into our applications. Now, when I do a talk, I kind of like to come up with a scenario to hang my talk off. And I gave a smaller version of this in December, and it was Christmas, so I kind of had a bit of a theme going on with Santa Claus and how do we make sure Christmas is a success. So I'm going to rebadge that today because it's Australia and Christmas in July is obviously coming up. So we're going to use a fictitious application that Santa and his elves have built to show you the kind of errors and how to go about diagnosing them. And here it is. Now, it's a really common type of thing that I see in customers. Essentially, Santa used to use an application called Santa Web to manage Christmas. So that would handle problems like the traveling Santa problem. How does he get around to all those houses on Christmas Eve? It's quite complicated. Naughty nice lists. Very, very complicated business logic that is locked up inside a legacy application, heritage application, let's call it. In this case, Santa Web was written in ASP web forms. It's pretty old. It had its own clunky username password. And Santa was managing a lot of infrastructure. So he decided to move all of this into the North Pole data center. I think I've called it the Azure North Pole Data Center. I don't think we have an Azure North Pole Data Center, but it would be kind of cool if we did. And in doing that, the elves turned Santa Web into a PaaS, made it run on app service, platform as a service, whatever, it doesn't matter which one it is. But they also looked to do a few extra things. You see, Santa was going for a digital transformation at the time, just like most customers, most companies out there in the wild today. So they outsourced their identity. They've decided to use Azure Active Directory to do that. And they've realized that the UX is clunky. So they wanted to unlock the possibility of new user experiences. So what they've done is they've created a whole bunch of APIs which are decoupled from the ASP.NET Web Forms to support new modern experiences that we want to build on top of that. Now, it just so happens there's another crack team of elves who fancy themselves as user experience deliverers, and they're very competent in React in this case. So they want to build Santa Lite, which is a single page application, and it's going to consume those APIs from Santa Web to make Christmas a beautiful experience. So the idea is they're going to use OIDC, authentication flow, to sign users into that application. And then they're going to use OAuth2 and get access tokens to call Santa Web APIs on behalf of elves and Santa. So one of the key things in there is a word called token. As we'll see through this talk, tokens are really the core currency of identity authentication and authorization when we're dealing with OAuth and OIDC. So that's the example I'm going to use. And what we're going to do is we're going to have a mix of kind of coding and a bit of kind of talking and showing you those tools and techniques to help find out what's going wrong, because I've heard on the ground that they have some issues. So we probably should jump into the code and see if we can find out what's going wrong to help the elves. Okay. So let's start in the S code. How is this going to work? Well, look at this. The demo got straight away. There we go. Awesome. Cool. Now, the elves decided to use React to write their application. And when they started, they were faced with their first choice they had to make. So whenever you're dealing with OAuth2, you don't want to roll your own library to handle tokens and deal with all the validations and checks and balances, because it looks deceptively simple on paper, but there's a whole bunch of security things that are built into those tokens. So you're best off going for a third-party library to help you deal with that. Now in the Microsoft space, we have two. We have one called ADAL, and we have one called MSAL. And it just so happens that the elves made the right choice in that, in this scenario, they decided to go with MSAL. We can see that inside their package.json. They've chosen a dependency called, MSAL Browser and MSAL React in this case. Now that's great because MSAL supports more modern, secure flows, which are not supported by ADAL. So be very confident when you make this choice that MSAL is the right way to go. The reason I brought this up is because I was doing a search on NPM the other day, which is the Node Package Manager, and it was quite interesting to see, I'll see if I can make my mouse work, that when you go to ADAL node on NPM, in the last week, there were 411,000 downloads of that package that has essentially been deprecated for about the last 9 months. It's on life support. So that's a lot of potential applications out there that are using inherently insecure flows. And that's not really a place where you want to be. That's okay. The elves chose right. They've gone with MSAL. So when they started, they had to set a couple of little parameters inside their code to wire this all up and to get it going. It's pretty straightforward. This is kind of a bare bones setup for an MSAL application. There's 2 bits of information we need, both really common definitions inside OIDC. We've got the authority and the client ID. Now, the authority tells our MSAL library where it needs to go to deal with authentication and authorization scenarios. Now, in this case, it's Azure Active Directory. So everything goes to a host name called login.microsoft.online.com. Now, if you're Auth0, you roll your own identity server, that's going to be a little bit different. In fact, on those types of service, you tend to have your own dedicated host name. We don't have that in AAD. We have a common host, login.microsoft.online.com. And then there's a GUID after it. So that's your tenant ID. Now, AAD is a massively multi-tenanted identity platform. So there are lots of other customers that also are inside there. So that's just how we can make sure that it's you that we're working with when we are doing authentication scenarios as opposed to other customers. Now, the second bit of information is called the client ID. So this is a really, again, common concept in OIDC flows, in that every application that wants to either get tokens or look at tokens inside OAuth2 is referred to as a client. So again, you'll have a client for every single application, be it a backend server or a single page application that you build, and these all have to be registered inside Azure Active Directory. It's the first bit of configuration that we need to line up. So if you just remember A47 and BE3, we're going to quickly jump into the portal and have a look at those inside AAD. So this is Graeme World, my own AAD tenant, and you can spin one of these up really easily. In fact, if you're in an enterprise, it's quite often useful to spin up your own tenant because you can then do a lot more. Like I'm quite restricted. There's a lot of things inside AAD I can't do inside my company tenant that I can in my own. For a learning experience, it's a really, really good idea. But here's my tenant ID, A47, and then we have these things called app registrations. Now, AAD doesn't just do OIDC. It does WS Federation, it does SAML, it does a lot of different authentication mechanisms that predate OAuth2. So it's the first point of confusion. We don't call them clients in AAD, we call them app registrations. But Santa Light is the BE3 one down here. And as long as those 2 bits of information, your tenant ID and your client ID map up, and you can see we even call out, it's your application, but yeah, all right, it's really a client ID as far as OIDC is concerned, then we're now in a situation where we can start to authenticate users. So let's jump into our amazing, I told you they were a good team of designers that we had with the elves. This is Santa Light, and we're going to start a sign-in flow and see what happens. So we click on the button, and the internet's working, so that's a good start. We instantly get taken to login Microsoft Online with A47, which is our tenant ID, and there's a bunch of query string parameters that we'll look at in a minute. But the point is, Santa Light has now taken us away to AAD to start the sign-in process. So I'm going to go and grab Santa's credentials, and we get prompted for usernames and passwords. So again,
which part of this is actually providing that UI? Is that the OIDC?
So this is Azure Active Directory that's providing this UI. So, and you can't customize this one, but if you're using B2C, which is the consumer identity, then you can customize that a lot more. So yeah, there's gets a little bit confusing. We can talk more about that offline if you want as well, B2C and AAD. So we click the sign in. Now the first thing that happens is AAD is being asked by Santa Light to ask the user to consent to provide it some information. So this is the crux of OAuth2. Basically, I'm a user, I want to use a third party that wants to do something with my identity. So it asks Azure Active Directory to ask me on its behalf to do that. In this scenario, I am being asked that Santa Light wants to sign in and read my profile. Okay, so let's click accept on that. And straight away. Now, this is a really, really simple problem to solve, but I do see it all the time. So being told that the redirect URI, Santa Light local test for me, does not match what's inside Azure Active Directory. Now, if we go back to the start of OAuth2, let's think about what's going on here. I'm an application, I'm being directed to Azure Active Directory to do something, to sign in. When that's done, AAD needs to take me back to my application and send back some information, which is one of these tokens that we spoke about. In the olden days, OAuth2 said nothing about where that callback had to be. So a lot of auth servers supported what we call wildcard redirects or open redirects. But that's a really bad security hole. Imagine if the Grinch span up his own Santa Light copy, looked like Santa Light, and he could get an elf to go and sign in Azure Active Directory, which would then blindly redirect to grinch.localtest.me and pass an identity token or an access token, right? You can start to see how Christmas could get spoiled because now that token's in the hand of the Grinch. So for Azure Active Directory to complete a sign-in, we need to not only tell it at the point of doing the sign-in where to redirect to, but it has to understand where those redirects are up front. And if it doesn't know the redirect, it won't do it for you. So that closes a security hole. It's one of the areas where OpenID Connect actually really kind of not just fixes, but makes a lot of the original OAuth2. It locks it down. It makes it much more safe to use. So in this scenario, we're going to go back into the portal in Azure Active Directory, and we're going to go to, should have got a piece of paper for my mouse mat. We configure redirect URIs against the application, and in this case, we can see we've got one single page application, and straight away you can see that this is not the one that was requested by the app. It's actually got sign in OIDC, so I'm guessing the else were originally using like an ASP.NET server-side application, potentially. That's a common URL we see in them. So this one's pretty straightforward. We're going to remove the suffix that we don't want, and we're going to save that. And we're going to go back to our application. Center light. And we're going to do the sign in again. And Santa. Lesson for my next talk, make sure to have a mouse mat by the computer. My optical mouse doesn't like this. And boom, we're in. My application knows that it's Santa. So what just happened? Okay, well, there's a few ways we can have a look at the different URLs and the different payloads that were invoked to make this work. I'm going to use a tool called Fiddler. Okay, but first of all, let's have a quick look on a PowerPoint slide of what's going on here. So we start off with our single page application. We click the login button. The first thing that happens is we get a 302 redirect. This takes us to AAD with 3 main bits of information. We've got what the application wants AAD to do, which is in this case to sign in our users. We've got the where to send me back to, that's the redirect URI. And then we've got a whole bunch of information around security concerns like state and nonces and things like that that just help with the checks and balances to make sure that things are okay. Now, one of 2 things is going to happen for a native application depending on the flow that you're using. If you're in ADAL world, or you're using a flow called the implicit flow, Azure Active Directory is going to send you back to Santa Light with a token. Now that token normally is stored in something like a hash fragment. this flow is not recommended anymore. It's got real security concerns around it with that token inside that fragment. So to give you a few examples of that, let's say you're in an enterprise that has got some SSL traffic sniffing firewall or something like that. It might intercept this and log the URLs to disk. So that could be a potential source of an ID token being leaked in there because it's in the URL. Or if you're a native application, I don't know who's done native apps here, but you can configure application-specific protocols on your apps such that if you invoke a URL on your device, that will launch your application. Now, the problem with those is that unless you're Google or Facebook, you don't get dibs on that application URI. Like, you can specify it, but someone else can have the same one. So whichever app is loaded by the device first is the one that's going to respond to that protocol. So if my redirect is my app : / and the Grinch releases an app called my app : / he could get the tokens that way because they may just get posted to his app by the device. So the problem with the implicit flow is that token in the fragment is just very, very insecure. It's very easy to leak that out. Another source is third-party JavaScript libraries that are running in with your application. They can look at the window object, for example, and a lot of these auth libraries leave those tokens on the window object, so they can be picked up from there as well. So a lot of places that can leak. So this is not the recommended flow anymore. Instead, what's come along is a flow called Proof Key for Code Exchange, or PKCE, as it's shortened to. So PKCE does something a little bit different. It doesn't send you back an ID token inside that fragment. It sends you back a code, right? And the idea is that that code is utterly useless to anybody but the application that requested the sign-in in the first place. Now, if you've done any OAuth or OIDC, you might have seen this before with a server-side application where the same thing happens. The auth server sends you back a code, but in that scenario, your application uses a shared secret to switch that code out for a token with the authorization server. Now, the problem with a native app, of course, is that a native app can't keep a secret. So there's no point bundling up one with your APK or your IPA package or putting it in your JavaScript because someone's going to grab that secret. It's not a secret. So PKCE is a little bit different in that a secret is created on the fly at the point of kicking off that authentication request. And what the PKCE flow is that we send the SHA of that one-time secret back to AAD. So AAD associates that SHA with the token that is associated with that code, and it sends the code back out. Now, in order to exchange that code for a token, you need the plain text that created that SHA in the first place. And if you can present that and the code, then we will give you back the token. Okay? So it's a way to bind the request for the token with the receipt of the token later. And it means that we're not sending that token in hash fragments everywhere, which is a much better security story. So what I want to do is use a tool called Fiddler, which is a networked kind of proxy debugging tool. And we're going to go and have a look at those flows. So when I did my authentication then, I was capturing traffic, network traffic in the background. So we can see all the HTTP requests that were going backwards and forwards. Now, the initial request for a token starts off at the authorization endpoint on Azure Active Directory. So I'm going to quickly find those calls to authorization. I'm going to take this one down here. And we can click on that, and we can go and have a look at the parameters that we sent to Azure Active Directory. We've told it who we are. That's the client ID at the top that we saw earlier. We have this property called scope. Scope is a really, really fundamental concept in OAuth2. The idea of a scope is it's something you can put in front of an end user that you can ask them to consent to. Think of it like Santalight has already got permissions to view profile details if only those users would actually let it do that on their behalf. So the scope is a way of asking for the user to consent for the application to do something. In this scenario, the important ones are OpenID, that says it's an OpenID Connect flow. It's authentication, not authorization. And then profile. So we basically want to see the user's profile. We have the redirect URI to Santillate. We just spoke about that one. Response type is really important. We don't want a token back, we want a code back. And the PKCE is the code challenge and the code challenge method at the bottom. So code challenge method is S256. This is a SHA-256 of something. And then the code challenge is that SHA. So AAD uses that, and when it dishes out the code, which we can see it should be the last AAD one down here. And let's see if we can have a look at this one. Now, it's always fun trying to find the requests that generate what it is you're looking for. That's the one that gives the token back. OK, for the interest of time, there's another flow in here somewhere where we can see AAD presenting the code back to the application. And to finish it off, Santillate goes back to Azure Active Directory and says, hey, look, here is the code. And, oh, that didn't work. Oh, dear me. There we go, cool. Here is the code, and here's the code verifier. So the code verifier was the plain text that created the SHA in the first place. And when we get those bits of information, AAD responds by sending us back, in this case, a bunch of different tokens, but the important one for authentication is the ID token. Now that is basically base 64 encoded JSON. So what we can do is we can grab this and we can use another tool to have a look inside it. So I'm going to use a tool called JWT.ms. You can also use JWT.io, that's fine as well. This one's nice for AAD tokens because it breaks down all the different claims to tell you what they actually are. But in essence, there's 3 points to a token. We'll call it the red part, the blue part, and the green part. The red part tells us what signing keys Azure Active Directory used to sign this token so that we can trust it's from AAD. Now there's another call which I didn't show you where we go to AAD and ask for its signing public keys. So we already have those, but it's now telling us which one it used to sign that. We've got the green part, that's just the digital signature. And then we've got the blue part, which is a bunch of information that we asked for, and it's now responded with. So quickly going through some of this, we start with, let's go for the preferred username. So this is an authentication flow. So we can see that it's center@grahamworld.onmicrosoft.com, and we have the name as well inside there. There's a bunch of timestamps issued at, not before, and expires as well. And there is a version, which is always a source of confusion in AAD. We have 2 versions, version 1 and version 2 of our endpoints. And then we have V1 and V2 tokens. If you use MSAL, you always hit the V2 endpoint. If you ask for an ID token, the version of the token you get back will always be the same as the version of the endpoint that you hit. So a V2 endpoint will get you a V2 ID token. That's different for access tokens, but that's the way these ones work. They're much the same, to be honest with you. V2 tokens are a bit smaller than V1 tokens. The other really important bit of information in any OAuth2 token is the AUD, or the audience claim. Now, in this scenario, the audience, B3, is the same client ID as my Santillate application that was registered inside AAD. And the golden rule of OAuth tokens is that if the audience isn't you, then you shouldn't really be using that token because it was never meant for you. And there's a really good example of that in tokens that are issued to call our Microsoft Graph APIs. So I've had customers call me before and tell me that their Istio JWT validation plugin was failing, and they want to know why. And they're trying to validate a Graph API token, but it's signed in a very weird way in that I think they create a signature, and then they add something else to the token after the signature is created. So you can't validate them, basically. But the point of it was that, well, you're not the audience, so it's kind of not yours to use or validate is that token. And that's a really, really useful thing to know, especially if you get weird issues like that. But look, that's the identity token. And that's the PKCE flow and how all of that hangs together. So with that, we're going to move on to the next thing. So we've signed in. We know who the user is. So the next thing we want to start doing is calling those APIs that are being exposed by SantaWeb. So we've got a button up here, which is to add Graeme to the naughty nice list. And let's click on that one and see what happens. OK, so let's put in Santa's password. Come on. OK, so it's another of these AAD consent windows, but this one's a little bit different to the one we saw a minute ago. This one is now saying that the app would like to change the naughty nice list on SantaWeb. So this is another example of a scope. What's going on here is that SantaWeb has exposed an API or a set of APIs to deal with managing the naughty nice list. And Santa Lite, the client, wants to access that. This is an example of incremental consent, by the way. So it's an application where, as we want to do things, we're going to start asking the user for extra bits of consent, as opposed to asking for everything up front, because that can be a bit daunting as a user, right? If you log in to view some information and you get asked to edit and delete and all these kind of higher privilege permissions. So this is just going to ask at the point in time. But where's that scope come from? What is it? Well, we can see there's an application which is called SantaWeb. So let's go and find that inside AAD and have a look at that. So we're going to go back up to Graeme World. And this time we're going to SantaWeb. And we're going to go into the Expose an API section. And what we should be able to see is that, if all goes well, ooh, could be my first demo, gotcha. Come on, AAD, don't let me down. OK, expose an API. Perfect, there we go, we're back in. The elves have already been here, and they've defined 3 scopes on this application. We've got naughty nice list write, naughty nice list read, and present delivery route.write. Now, scopes are all there for the end user experience. Scopes don't necessarily map one-to-one to the back-end APIs. So there might be 15 or 20 APIs involved in managing the naughty nice list. But we wouldn't want to be prompting an end user for each and every one of those, because that consent experience is just going to be too much to take. You're asked for a list of 50 APIs to consent to. Yeah, sure, whatever. So scopes allow us to create something that makes sense in front of a user. And then that may map to multiple APIs behind the scenes. But in this, as far as AAD is concerned, it's really just a piece of text is a scope, right? There's nothing that special about it. And we can have a whole bunch of these against an API if we want to, against an application, sorry. Now, do you see that prefix with API://SantaWeb? So whenever we create an application inside Azure Active Directory, there are a bunch of different IDs that uniquely identify that, which can be a bit weird at times. We have the application or the client ID, we have an AAD object ID, and there's another piece of information that we can specify that's called an application URI. Whenever we ask for a scope from Azure Active Directory, we can't just ask for the name of the scope, in this case, naughty nice list.read. We have to fully prefix it with the application's URI followed by the scope name. Now that's a little bit different to say auth0, where when you ask for a scope, there's another piece of information you send, which is the resource that you want to get a token for. Because a JWT, an OAuth access token, only applies to one audience. There's only one API we can give this token to, which means that all the scopes have to be from that API. So it's a little bit strange in AAD in that you can ask for a token with scopes from multiple APIs, but it will reject that request and just say, no, it has to be from the same API. Now, in this scenario, I've explicitly set my application ID URI to be API SantaWeb. And then if we go and look at the React code, on the naughty nice list button, we can see that I'm using a MSAL method called acquire token pop-up, where I'm asking for API Santa Web present, naughty nice list.write. So let's go and, now I'm just going to cancel this. I had some issues with this one the other day where my actual token request expired. So let's kick it off again and see if we can get a response from AAD. We'll accept the consent, and we get a token back, and that's now going to try and call the API in the back end, and we get an unauthorized response. So that's interesting, right? Something looks okay. We've got a token, but there's a problem somewhere else. So let's start by grabbing the token, and we're going to drop it into JWT.ms and have a look at it. So it's a bit different. This is a V1 token we can see down here, but let's not worry about that too much. It's just a bigger token. It's still an access token, not much difference. We've got this SCP property in here now. So that's the scopes that the user has consented to. So we can see that Santa in this case has said, yep, you can call the naughty nice list on behalf of me. I consent to that. The other one I want to call out is the audience at the top. So in this scenario, the audience has now changed to API://SantaWeb. So in an access token, the audience will be that fully qualified application URI on the scope that you asked for. There's a little caveat in that you can ask for another scope prefix of the client ID, and it will then give you a token with the client ID as an audience. But on the whole, you'll use the application ID URI. So this looks pretty good to me. I've got a token, but for some reason, something has failed. So I'm going to go to the back-end application now and see what happens. So this is a .NET Core application. We're using a library called Microsoft.web.identity, and we've had to configure it with 3 bits of information, pretty similar to the MSAL client, just different names. We use the tenant ID, which was the GUID at the end of the authority. We've got the instance, which just points to Azure Active Directory, and we have the client ID, which in this case is the unique ID of Santa Web. And we have nothing else inside there. But if we look at the log file, what we can see is that we've been told audience validation failed, IDX 10214. So I see this a lot with audience issues in Azure Active Directory. It's a quirk of AAD, especially the Microsoft libraries, in that if you don't explicitly specify an audience, we will kind of make one up based off other data that we expect those tokens to have. In the portal, you can ask for a default application ID URI, and we just set it to API:// and then the GUID of your client. And that's what that's what Microsoft Web Identity will expect on the token if you don't tell it otherwise. There's a subtlety as well. There's a weird bit of code in the backend library that says, if it's a V1 token, I expect API:// client ID. If it's a V2 token, I expect the client ID. That's one of a source of confusion that I've seen surprise a lot of people doing this. But in this scenario, all we have is a controller, ASP.NET, and you can see we've got a post method to the naughty nice list, and at the moment it's just got a required scope on there. So what we want to do is inside our app settings, we're going to tell Microsoft Web Identity what the audience should be on the token. So it's just API:// Web. And then we'll restart the application and we will try that again and see what happens. So while that's moving, let's go back to here and add Graeme to naughty nice list. The default isn't to always prompt you every time, by the way. I've just done this to make the demos a bit easier. We actually will cache tokens in the background to make things a bit better. So if all goes good, perfect. So that's the second issue I see is audience is not set up correctly. If you're using Azure App Service as well, this pops up a lot if you're using the authentication feature that we have built into it. So you have to be very explicit on the audiences with that. And I've had quite a few calls where it's not set up properly. So it's just one to be aware of. But again, we can see the tokens, we can look at the configuration and the flows and get a good picture on why things aren't working. So this is awesome. We have managed to now call the downstream API with an access token. So I've heard there's another problem though. So I'm going to log out Santa. Now, there's a fairly cheeky elf in there who's called Alabaster. And he's been digging around this application and has realized something. What he's discovered is that if he signs in, which is the same flows and everything, and he can consent to the same permission that Santa has been consenting to, which is to manage the naughty nice list. Now, Alabaster is really not a senior elf, so he's got no business to be inside this part of the system. But he can get prompted for consent, and he can call the API. Now, this is something in Azure Active Directory to be aware of, which is that as a user, well, let's start with the application. If there's a permission configured on an API, then it's really the application can prompt anybody to consent for that permission, right? So just because you can consent someone if they want to do something doesn't mean they're actually allowed to do that. So scopes aren't permissions, right, at the end of the day. Scopes are really there just to get delegated consent to act on behalf of a user. It doesn't mean that user is necessarily able to do that thing. Okay, scopes aren't permissions. Now, some authorization servers do actually allow you to map users to scopes. So I think Identity Server was one way you could literally create a scope and then restrict which users could even be shown to ask for consent. But with AAD, if you're a user, if you're allowed to use an application, we don't restrict which scopes you're allowed to consent to. We will give you a token with them in. So what are we going to do? Well, there are a few different ways I can think to solve this problem, right? The first is fairly old school. We have Active Directory groups. Right? Who doesn't love seeing your name in about 1,500 AD groups that have been defined over like 30 years of an enterprise for applications that no longer exist even anymore, right? It's pretty painful. It involves the AD team, which is normally quite painful to make changes in AD, which is probably not a bad thing, to be honest with you. But it's very detached from your application, is Active Directory. Active Directory is like an organizational concern, right? And in my opinion, AD groups should really represent quite high-level organizational constructs. So maybe that is that I'm a developer. That's fairly organizational level. Or somebody works in marketing, or there's a mentors group. They seem like really good natural fits for AD groups, not very low-level application concerns. There's a bigger problem with JWTs and Active Directory groups as well, which is that when you're in an AD group, we start putting those groups on every token that we send back, which has you as the subject. So those groups grow and grow and grow and grow, the tokens get bigger and bigger and bigger, and then we hit a limit. And at that point in time, we don't put any more groups inside that token. So that could leave you in a scenario as an application where if you're lucky, the group might be in the token. If you're not, you might have to make another call off the graph to work out if the user is really in the group that you want to find them in. So not a great place to be in. Now in AAD, we have another construct which is a much better fit for this, that's called a role. So roles are like groups that are really scoped to your application inside Azure Active Directory. And they give us a much better location to put application concerns. And the idea is that we can define roles against an app, and we can assign users and groups to them. And then when we get a JWT back for the audience of that application, we will show you the roles that that user is in, that are defined in that application. So they're pretty straightforward to define. let's go into Santa Web. And we have this tab down here called App Roles. So if we select that, we can see there are two defined. We've got Santa World Employee and Santa World Senior Employee. So the idea is that you should only be able to manage the naughty nice list if you're a senior employee. So how do we get users into that? Well, we've talked about applications so far, but AAD has got this other wonderful thing that goes hand in hand with an application that, depending on which day of the week it is either called a managed application, an enterprise application, or a service principal. Each name really makes very little sense to me, and it took me a while to actually understand what was going on. But the idea is that an AAD application is really just definition, it's metadata. It's not a thing that you actually really interact with, or you hang users off, or users sign into. Instead, what happens is that for every application, if you want to use that inside your AAD tenant, you need to create what's called let's call it a service principal, which kind of goes hand in hand with that. It's literally like the manifestation of your application inside a directory. And that's where we can start hanging things like real users and blocking users from accessing the application in the first place, looking at who's signed into it, all kind of things like that. Conditional access are done against the service principal, not the application. There's another way we can set an application up, which is in what we call a multi-tenant form. And it probably makes more sense in that world, because with a multi-tenant application, we only define it once, but then we can have other directories that want to consume, let's say I'm a SaaS provider, they want to use my SaaS service, they can create the service principal in their directory where they can assign users and access and conditional access and things like that. So when we want to assign users to a role, we have to go into the managed application, service principal, enterprise application, whatever we want to call it. And in here, we can effectively go to users and groups, and we can start getting much more specific about who can access this application, or indeed if anyone can access this application. So let's go and find Santa, and we will select Santa. And when we go to role, the only roles that we are offered are the ones that were defined against the application object. So in this case, I'm going to make Santa a senior employee. It's probably more than a senior employee is Santa. And we will assign. And now let's go back to Santa Lite MSAL, and we'll sign out and sign back in as Santa. So sign in. And let's go and find Santa. Didn't remember it. And sign him in. And then we'll click to add into the naughty nice list, and we'll have a quick look at the JWT first of all that comes back. Accept. There's your token. Let's put that into the third one over here.
Is that access or refresh?
So this is an access token. Yeah. And then you can see now that we get this extra array come back of strings, which is the roles that Santa's assigned to. Now, what we can leverage in the backend API is we're using standard ASP.NET authentication and authorization here. So we can start to use our bog standard authorize attribute, and we can say that we want in this scenario, it's the roles that we're interested in. And then we just go and find that particular role, senior contributor.
I thought it was senior employee.
Oh, is it senior employee?
Yeah.
Oh, man. What's going on there then? Okay, yeah, that's my demo bad. Basically, there's a human visible version of a role, and then there's the actual sort of key of the role that you get back. So I think in this scenario, what I've done is the senior employee is actually called senior contributor. So that's the one that comes back in the token. Thanks for pointing that one out, whoopsie. Okay, great. So we are going to check for that particular role in the token. So now when we run this, then for Santa, all is going to go well, and we're going to be able to call that API. But if we were to get a token as Alabaster, then of course we're not going to have that particular role inside the token, and the authorization step will fail. So just to kind of finish that one off, in this scenario, I think it worked last time anyway, because we didn't have the auth on there. And happy days, hopefully. Failed to fetch. I'm not sure what's gone on there. But anyway, that's okay. You'll have to trust me on that one, in the interest of kind of not fixing my broken code. That one should have worked. And if we do the same as Alabaster, we don't have the role inside the token, so everything fails. So really, that's what I had to walk through today. I think we've covered a fair bit. If anyone's interested, there's the crazy code inside Microsoft.web.identity, which looks for specific versions of tokens and then hardwires a different expected audience depending on which one it is. There's a link on the slide deck as well to that code if anyone is interested in that. But ultimately, scopes aren't permissions, and that's the really important thing I want to get across. Now, really, roles aren't great for permissions either. They're good for segregating users into your application. But as your business logic starts to get more and more specific, then you really don't want to be outsourcing that into a third party like AAD. Like, you don't want to get into a trap of having roles called something like can transfer more than $100 or is allowed to transact on a Monday, right? That is business logic concern. And either get that inside your application or look to something like a policy server, potentially, if you want to outsource that. There's a good talk tomorrow morning that Jason is doing early about ASP.NET Core authorization policy. So if that's something that you're interested in to take that next level into getting application business authorization rules, then I fully recommend going to that talk. But that is everything from me for today. So really appreciate you all coming, and I'm sure we have a few minutes potentially for questions, if there are any. So thanks.
You mentioned OIDC, but I don't fully comprehend its role in this process.
Yeah.
Can you shed some light on what it's bringing to the table?
Yeah, sure, right. So in the beginning, there was OAuth2. And OAuth2 was a very loose framework on how to build an authorization framework. And it was possible to be like, adhering to OAuth2 whilst having quite different implementations of your different implementations. OAuth2 is also just an authorization protocol, right? So its main purpose was to get delegated consent of a user really to consume their Facebook profile. But it said nothing about authentication. So what happened is a lot of the big providers built their own authentication APIs and used OAuth2 to get tokens to access those. So you had this like proliferation where signing with Google, signing with Facebook, signing with this service, they all did it in a slightly different way. The claims are all slightly different in the tokens. So OIDC came along and really started to come up with a more standards compliant way of implementing OAuth2 as a framework. So that might be a case of saying, well, look, OAuth2 said you could do this and you could do that, and maybe you could do this, but you don't need to worry about that. OIDC said, no, this is how you do it. And then it also added this new token called an ID token, which basically fixed in quotes, the authentication problem and gave a standards compliant way to just work out who somebody is without asking them to access another API. So I quite often interchange, and I'll say OAuth2 or I'll say OIDC. And I never really know which one to say because it's not like it's an umbrella. It's not like it replaces OAuth2. It's more like it has these extensions to auth2, and it also just kind of makes it a little bit more concrete around how to implement auth2. So when you look at Azure Active Directory, for example, I refer to it as like an OIDC compliant authorization server that will give you also OAuth2 tokens as well as identity access tokens. But I'm happy if anyone else, so a lot of what I know about this, I worked with some really smart people at Bankwest a few years ago and learned a lot from their identity team. So I'm happy if anyone else in the room wants to extend that answer, then please go for it, because yeah. Yep, sure.
What's an RFC?
An RFC, a request for comment, I think it stands for. So if you want, this is a good one. I'm sure someone will give a much better answer for this. Say you have an idea and you want to think about standardizing that idea. So the general approach seems to be put it out as an RFC, and then it will have a lot of kind of debate and discussion and feedback, go through various versions until it kind of hits a point where it's considered, stable enough and the controversy has died down. So yeah, and then different things referred to as different RFC numbers. So private network addresses like RFC 1819, it's where a bunch of people just said, nah, these IP addresses, we are going to say they are private use only, they are not public, and that's pretty much standardized in RFC 1819. So OAuth2 and OIDC also have RFCs that go with them as well.
Right, so who's responsible for implementing that RFC? For example, Azure AD versus
Yeah, right. So it's normally a coalition of the willing. So you'll find a lot of the RFCs will have people, if there are enterprise products involved, they'll often have representation from the vendors of those products, but also there may be academics, just people that are really interested in that domain. So I think it's kind of a public domain thing. I'm not sure if there's a method to choose who gets to contribute in it or not. That's possibly a level I don't really know at that point, but yeah.
In the AAD console, so you're working in the section called app registration.
Yeah.
How does that differ from the enterprise applications section, which is also used to set up SSO with applications in AAD?
Yeah, right. Okay. So which bit of it in particular was it you were thinking about in there? So
I haven't set up any applications yet in this way exactly, but I have worked in the enterprise applications section when you're registering like a third party.
Oh yeah, right. Okay.
SAML applications.
Cool.
And you wanted to sign in through AAD.
Yeah. Okay. Sweet.
And
Yeah.
it looks like there's some similarities in what you would configure.
Yes.
An application there versus here, and you set up a client ID.
Yeah, right. So what you're probably doing there is setting up a multi-tenant application. So when it comes to SaaS providers, I was doing some work with one the other day. They own the application registration, right? So you never see that part of the portal. You can't access it. It's inside the SaaS provider's tenant. But what you can do is you can craft these links that allow an AAD administrator to create an instance of a service principal that represents that application in their directory. So it's possible that that's where you're at, is inside that service principal that represents a third-party application. And that's where you can start assigning users to it. Yeah.
So it's more about whether it's a third-party application or something in-house that you're building specifically to work with.
Right. Yeah.
Linking something that.
Yeah. So if you want to do sign-in flows in AAD, then there has to be an application somewhere, and there'll be a service principal in the tenants where you can sign into that application. There are scenarios where you can have service principals without applications as well. So if you use Azure and you create a managed identity, you'll get a service principal without an application, and you can assign RBAC to that service principal, for example. But yeah, if there's a sign-in flow, there'll be an application somewhere. Yep, so perfect.
In a world where everybody has identities stored in all these different other providers, creating a React application to interact with each one of those would be a pain. It's Microsoft looking to do it to kind of offer
Yeah, yeah, so the question is around multiple identity providers. If you want to build a application that can do sign-in against all of those, can be a real pain. I don't know the Azure Active Directory roadmap, but I do know that B2C does support federation. So you can front a whole bunch of different identity providers with a B2C sign-in page. Now that having said, B2C sign-in doesn't give you access to like authenticator and all of that kind of conditional access stuff. So I think there's still some gaps there, but I'm not sure what's on roadmap for closing those, if anything. Yeah, go for it.
OIDC, it's got a lot of capability in there,
Mm.
driving what you want to hear on your login screen by the way of displaying not the prompts or the UI locale.
Yeah.
Through the group room. How compliant is the OIDC implementation inside of Microsoft AD?
Yeah, I don't think there's much you can change on AD, right? So B2C is one way you can get a lot more customized flows, defining your own UIs and all that kind of stuff. That having said, there possibly are some parameters you can tweak to change that experience a little bit. I just haven't done too much on that, so I'm afraid I don't have a great answer, but I'll take it offline and find out for you. Cool. Okay, so well, look, thank you everyone for coming, and yeah, enjoy the rest of your conference. Cheers.